Okay, let's take a look at our next method for solving quadratic equations called completing the square. Sometimes we have quadratics that cannot be solved by factoring, and what we can do is use this method of completing the square to make it factorable on one side and then solve. So we'll take you through a couple examples. So this cannot be solved by factoring. So the completing the square method is outlined right here. So to solve a quadratic, first thing we're going to do is we're going to subtract the c value, which is the constant from both sides, then divide by the leading coefficient if there is one, and then we're going to compute a little calculation here, 1/2 of b over a, and then square it, and we're going to add that to both sides. And what that does is it creates a perfect square trinomial on the left hand side that we can factor. And then we're going to factor that side, simplify the right hand side, and then we're going to use our last property, which is the square root property, to solve. So let's take a look at two examples of that. Okay, so here we have a quadratic. It's in standard form, it's ready to go, so we're going to subtract c from both sides. So we have x squared minus 6x, and leave a space here because when we're in step 3, we're going to add something to both sides, so we're going to be putting it in this space right here. So equals a -2. Now our leading coefficient is 1, so if we divide by 1 we get the same thing. So let's move on to step 3, and we're going to compute this 1/2 b over a squared. Now always go back to the original equation written in standard form to get your values for a and b. So I'm going to write this over here to the side. So I have 1/2, and our original b value was -6, and our original a value was 1. And then we're going to square that. Well, if we multiply that all together, we get -6 over 2, which is -3, and then -3 squared is equal to 9. So that's the quantity that we are going to add to both sides. So we're going to put that here on the left and on the right. Now we end up with a perfect square trinomial on the left that factors as a binomial square. So we have a real quick shortcut for that. Square root the first term, which is x, square root the last term, which is 3, and then the sign of the middle term, and then a squaring of that binomial. Our right side is equal to -7. Sorry, +7. And then we can apply the square root property. So we're going to square root both sides, and we have x minus 3 is equal to plus or minus the square root of 7. Add 3 to both sides, and our answer is x is equal to 3 plus or minus the square root of 7. And you'll see that that's two solutions. If you're asked for the decimal equivalent, you can type that in. 3 plus the square root of 7, get your answer. 3 minus the square root of 7, get your answer. Okay, let's take a look at number 10. This time we have a leading coefficient, so we're going to have to look at that step number 2 in more detail. So step number 1, subtract c from both sides. So we're going to add 5. So we end up with 3x squared minus 4x, and we'll leave that space, is equal to 5. We do have an a value of 3, so we're going to have to divide everything by 3. So we have x squared minus 4/3 x is equal to 5/3. Now step 3, we have to figure out what we're going to add to both sides. So let's sketch this out here at the side. So we're going to have 1/2 times, and again, look back at your original equation. Our b value is -4. Our a value is 3. And we're going to square that. So that simplifies to -4 over 6 squared, which is -2/3 squared, which then simplifies to 4/9. So we are going to add 4/9 to both sides. And again, we end up with a perfect square trinomial on the left-hand side. So square root the first term, square root the last term, so that becomes 2/3, Sign of the middle term is negative. And then we have 5/3 plus 4/9. Let's get a common denominator of ninths. So this would be 15/9 plus 4/9, which gives us 19/9. Okay, we're on to step 5, using the square root property. So we have x minus 2/3 is equal to plus or minus the square root of 19/9. Add 2/3 to both sides, and then we're going to simplify this radical. So we get a positive 2/3 plus or minus the square root of 19/3, because the square root of 9 is 3, and that is our final answer.